This time on Battle Factory. The scope that's right on target from 2.5 kilometers away. An airborne supply system that delivers the goods from 9 kilometers up. These boots are made for marching. And one of the most imitated handguns ever made. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. This aluminum block will soon hold a piece of ground glass that has the power to extend a sharpshooter's eye, so he can see, stalk, and connect with a target that's kilometers away. The rifle scope is small, lightweight, and has a revolutionary fog-proof lens, so the glass will not fog up no matter what the weather. The sophisticated rifle scope began in the 17th century as a set of crosshairs, actually made from human hair or spider webbing, and mounted on the tip of a rifle barrel. But today, with advances in rifle and scope technology, elite snipers have made record shots at seemingly impossible distances, up to 2.5 kilometers from their target. The loopholed rifle scope breaks down into the lenses, the Erector system, and the main body. The body starts as 3.7 meters of aluminum tubing. The blanks are placed in a computer-controlled cutting machine where they rotate on a spindle. First, the eyepiece end is cut. Then, the objective end, the side that faces the target, is machined. Rifle scopes have 3 main sections that magnify an image: the objective lens, the internal Erector lenses, and the ocular lens. As the light passes through the series of lenses, the image starts upside down and is then flipped back before being magnified. Next, the Erector system of the scope is machined. The pivot tube, which will hold the internal lenses, and the cam tube, which slides over top and controls the movement of the lenses back and forth. Next, the eye shell and lens holder is machined and washed. Finally, mounting rings are cut. These will fasten the scope to the rifle barrel. The rings are then stamped with a logo and set aside for coating. Next, it's sandblasted to prep the body to be anodized, a chemical treatment that coats and protects the aluminum. During the Vietnam War, the legendary American sharpshooter, Carlos Whitefeather Hathcock, became one of the Viet Cong's most feared snipers. An equally lethal Vietnamese sniper known as the Cobra was enlisted to take him out. Meanwhile, Hathcock was tracking the Cobra. While stalking his adversary, Hathcock caught a momentary glint in the undergrowth and fired at the reflection. He sent a bullet directly through his enemy's scope, killing the Cobra. Later, Hathcock realized the only way he could have made the shot was if he and the Cobra had been looking directly through their scopes at each other at the exact same moment. Lucky for him, Hathcock fired first. After being anodized, the scope is now a matte black. All the anodized parts are placed in a carrier basket and ferried through a series of tanks containing detergents and cleansers that prep them for a 100% sterile environment. In a clean room, the eyepiece is assembled. Then, the rings are glued together and the ocular lens is dropped onto the eyepiece. Then, the Erector system is assembled and the main tube is put together. Once the scope is fully assembled, it is calibrated to make sure the optics and mechanics line up perfectly. When a sniper is taking aim, he may not be putting his target in the crosshairs, but adjusting his scope to compensate for distance, temperature, and wind velocity. The scopes are then inserted onto blocks, and a tiny piston shoots inert gas into the main tube. This will prevent fogging in the field no matter what the temperature or humidity. Then the scopes are fitted onto a carousel and put through the dunk test. If any bubbles are visible, that means there's a leak. Finally, the adjuster tubes are added for wind variation, elevation, and focus. The scope sits securely on the rifle barrel. The shooter squints through it, putting his target in the crosshairs, making minuscule adjustments. This refined melding of precision optics and crafted mechanics all come down to one moment and one shot. Coming up on Battle Factory, the airborne care package that can find its own way to the drop zone, and military footwear from boot camp to the battlefield. When they're packed up, these containers will be giant care packages, bringing airborne aid that can make the difference between help and being helplessly stranded. And not only can they fly, they can get there on their own. Precision Aerial Delivery System, or PADS, are guided by GPS. Computer coordinates program the airdrop, and built-in motors using pulley systems steer the package for up to 15 kilometers, transporting loads of supplies and landing within 100 meters of the drop zone. While the military had been dropping bombs out of the sky since World War I, it was only in the Second World War that they began using their planes to airdrop food, medicine, or weapons to soldiers operating deep behind enemy lines. But these airdrops were hit and miss. Packages often landed kilometers away from their targets. Today, NATO considers precision airdrops among its top priorities for humanitarian aid and defense against terrorism. The Sherpa model breaks down into the parachute, the payload, and the guidance unit. The black box, called the Aerial Guidance Unit, consists of two small metal compartments that fit together. The first step is to assemble the upper half, or the muscle of the guidance unit, which contains the basic driving mechanisms and pulley system. The pulley system will tug on the parafoil's lines to steer the Sherpa to its drop zone. The lower half is the brains of the unit. It houses the GPS software that can track where it is and where it's headed. A stack of computer cards receives location information from the GPS receiver. It computes a flight path to the target point and instructs the parachute when to open. The onboard receiver means that the unit can also be controlled using a remote control. A battery is installed and the two halves are assembled. Now, the aerial guidance unit is ready for rigorous testing. If the drop is from 9 kilometers over the desert, the temperature starts at a freezing 50 below, then soars to plus 40 as it lands on the burning sand. So the pad's computer and mechanics are tested at extreme temperatures. The parafoil lines are connected to the AGU, and under simulated flight conditions, the steering mechanism is stressed to its limits. When it's passed the test, it's ready to be connected to the parachute. The parafoil is what makes the Sherpa fly. It's made from double layers of super strong parachute material called ripstop nylon. Once it's sewn together, every centimeter of the material is checked. Even the tiniest nick could shear it and bring a huge payload crashing down. When the space between the two layers of chute material fills with air, the parafoil becomes a rigid rectangle, like the aerodynamic wing of an airplane. A Sherpa can have up to 100 suspension lines made of very strong nylon, which is built to hold 10 times the weight of their designated payload. Once the lines have been methodically organized and laid out, the chute is packed into a bag. 2004 was the first time a GPS-guided PADS was used. A U.S. headquarters in western Iraq that was home to a hospital and Marine garrison was at risk of heavy insurgent attack. The only way to get the much-needed supplies was from the air. Deployed from high above enemy detection, the newly developed PADS floated downward and steered itself to the correct coordinates. The food and medical supplies landed safely in the camp. The final step is to integrate the guidance unit and the parafoil. The PADS has the brawn to deliver 4,500 kilo care packages to their destination and the brains to get there on its own. Coming up on Battle Factory, the boots that form a soldier's footsteps, and the world's most popular pistol. When these strips of leather are cut and cobbled together, they'll march a Marine through a life of service. The Army boot is a symbol of military life that takes the soldier from the parade ground to the battlefield, but they aren't all created equal. The Danner rugged all-terrain boot is built to keep the U.S. Marine warm, dry, and protected, whether he's trudging through a desert or slogging through swamp. But it's been a long haul getting here. The trench boot took its first steps during World War I in the cold, wet mud of Europe's Western Front. Made from rough-cut leather with hobnail soles for additional traction, the boots were coated with wax dubbin to waterproof them against the persistent damp and the threat of trench foot, a disease that caused a soldier's feet to literally rot in their boots. But the coating wasn't enough, and 75,000 troops succumbed to trench foot. As military theaters changed, design of the military boot had to evolve along with it. The Danner all-terrain boot breaks down into the liner, the sole, and the exterior. The first step is to check the leather for quality and strength. Then the hides go to the leather cutting station. Steel dies cut out the patterns that will form the outside of the boot. The leather is then stamped with the official insignia of the United States Marine Corps. An automated sewing machine double stitches the boot's leather quartered panel with extremely strong nylon thread. Then the rest of the pattern is hand sewn to complete the side panel, which will keep the ankle dry and protected. 12 eyelets are punched out for laces, and then the side panel of the boot is sewn together. Once the excess leather is trimmed, the exterior of the boot is complete. Using dies that look a little like Christmas stockings, the boot liner is cut out of waterproof, breathable Gore-Tex. The pleated halves are stitched together using a surging stitch that can easily accommodate the curved shape of the liner. The booties are then inflated with air and dunked into a water tank to check for holes. Bubbles indicate a leak, which means they are either repaired or thrown away. These Gore-Tex liners ensure that the boots can tramp through ankle-deep water without getting the soldier's feet wet, making the boots 100% waterproof. The boot is ready to be put together. First, hooks are added for speed laces, just like on ice skates. The lining is stretched into shape on a plastic foot mold. A felt insole board is coated with glue and pressed onto the bottom of the lining. The top layer of the boot is glued on, and the leather is stretched right over the toe. The boots and rubber sole are heated to over 90 degrees Celsius to activate the adhesive. A tack clamps the boot and sole together to complete the watertight seal. First, they test the sole's bond to the boot bottom. It takes almost 115 kilos of force before the sole gives way. The laces and eyelets are jerked around over 15,000 times and still refuse to stretch or tear. Then the boots are dunked in water and flexed 100,000 times to simulate a tour in swampy terrain. Life is tough enough for a Marine without worrying about what's underfoot. The right pair of boots isn't just part of the uniform. They're as critical to a soldier's survival as their weapon. Coming up on Battle Factory, a straight shooter that aims for accuracy. These bits of steel and spring and coated plastic will pack into a pistol that's one of the most popular sidearms ever produced. Designed in the Czech Republic, the CZ75 9mm pistol was first designed in 1975 behind the Iron Curtain. Its firepower and accuracy became legendary and has since been imitated by manufacturers around the world. Today, the CZ75 is the default sidearm for a long list of police and military forces. The pistol breaks down into 4 parts: the frame, the recoil spring, the barrel, and the slide. Every time the pistol is fired, recoil slams the slide back and pops out the spent shell. Then a spring bounces the slide forward, chambering a new bullet as it returns to firing position. The slide starts out as a piece of raw steel. A robotic arm grabs it and puts it into a computer-controlled cutting machine. The machine then carves out the basic shape. Automatically selecting from a series of cutting tools and drills, the machine further refines the slide, rounding the edges and cutting out an ejector hole to jettison the spent cartridges. Every member of the U.S. Special Forces, like the legendary Delta Force, is armed with a pistol. When a Black Hawk helicopter was shot down in Mogadishu, Somalia, 2 Special Forces snipers insisted on being airdropped into the fray in order to defend the wounded crew under siege by a mob of Somalian insurgents. Armed with only their sniper rifles and pistols, they established a perimeter to protect the wounded crew. The first soldier was killed, and the second stepped directly into the line of fire, holding them off with just his pistol until the very end. For the first time since the Vietnam War, both brave soldiers were posthumously awarded the Medal of Honor. The barrels of the CZ75 arrive coated in rust. They're actually left outside during the changing seasons to be weather cured, which toughens the metal, a CZ family recipe. The barrel is made from a special alloyed steel, heat treated for hardness. Holes are bored through the center, 4 barrels at a time. Then the rusty outer bark is scraped off. The barrels are placed in a cold hammer forge. 4 hammers pound on the barrel at 1,000 hits per minute with 10 tons of pressure to stretch and toughen the steel. During this hammering process, a spiral-shaped tool forms corkscrew grooves on the inside walls, called rifling. When the bullet is fired, the rifling causes it to spin, which makes it fly straight and aim true. Then the rifling is inspected and the interior of the barrel is cleaned. The frame is made from a super-strength polymer reinforced with fiberglass. The spring absorbs the energy of the recoil and protects the frame from the impact of the slide. Every time the pistol is fired, the recoil sends the slide back into firing position, chambering a new round as it goes. Finally, the slide and barrel are joined with the frame. The gun is complete and ready for testing. Every CZ pistol is strong enough to be dropped from 4 meters with a round in the chamber onto a concrete surface. It will hold together and the coated polymer frame won't crack under impact. Finally, the gun is loaded up and lit up at the firing range. Since its inception in 1975, there have been literally thousands of imitators of the CZ handgun. But whether it's on the firing range or the combat zone, when you need to give it your best shot, you want to reach for the real thing. This time on Battle Factory, a remote-controlled eye in the sky, a hard-shell case that's an ER you can drop from a plane, how to keep yourself safe from the storm and hidden from prying eyes, and a monster truck that can really take a bullet. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. When this construction of cogs, cables, and computer software hits the air, it'll become a flying eye in the sky and a high-tech bird of prey. UAV stands for Unmanned Aerial Vehicle, but these remote-controlled flyers, used for long-range reconnaissance and armed combat, are better known as drones. They come small enough to fit into a backpack or scale right up to a full-size fighter jet. It can outfly manned aircraft, staying aloft for over 24 hours at a time, often controlled via satellite link from a world away. The ING Robotic Aviation Responder is a surveillance drone that can reach speeds of 70 kilometers per hour. Weighing in at 45 kilograms, the $80,000 Helidrone is stable in extreme weather conditions and 60-kilometer winds. The Helidrone is currently deployed to East Africa, where the military use it to monitor border incursions. The Helidrone breaks down into the motor, the drives, and the frame. The minicopter is made on a frame of carbon fiber, which is 10 times tougher than steel. The rest of the body is composed of strong, lightweight fiberglass, which won't disrupt the radio frequency signals that control the drone. The main gear drives the aircraft's main rotor and tail. All teeth on the gears are manufactured on a diagonal instead of straight up and down. This minimizes noise and vibration throughout the frame, which maximizes stability and stealth. Just like a full-sized helicopter, the drone is based on angled elements that provide lift and prevent the aircraft from spinning out of control. There are two drive systems, one in the main body of the frame and one in the tail. This two-way drive helps to stabilize the drone so it doesn't spin and helps with the yaw, or left and right turns. The drives are made of CNC machined aluminum. First, the tail drive is assembled. Next, the main drive is constructed. The main drive is responsible for the lift of the drone. Its curved holders steady the aircraft and minimize spin. Surveillance drones were first used extensively during the Vietnam War. Dubbed Firebees, they were equipped with conventional cameras and ran reconnaissance missions. Not much change for UAVs for 20 years, until drones were able to see details from half a kilometer up and transmit those images in real time. And the sound of a drone often meant an attack was going to follow. So, in February 1991, after a U.S. battleship had devastated the Iraqi defenses of Failaka Island near Kuwait City, the Navy sent an unarmed drone at low altitude over the island. When locals heard the drone's signature sound, they figured the low-flying aircraft was about to direct another precision strike. The troops started surrendering to the drone's tiny camera. It was the first time in history that people surrendered to a robot. Assembly begins with the landing gear. The lower landing portion is made of lightweight aluminum. The raised legs allow for 8 inches of clearance for mounting cameras and large sensors. The copter is wired and the onboard computer and power source are installed. The 500-watt battery-powered motor will reach speeds of 70 clicks and run for about 40 minutes without a recharge. Finally, the propeller blades are inserted into the main and tail drives. The responder is made to carry a DSLR camera, which takes super high-resolution stills and video from as high as 275 meters up. Top priority for the drone's test flight is to make sure the UAV is vibration-free. Even the slightest rattle makes for a bumpy ride, a drained battery, and blurry images. Drones are on the rise. Whether it's deployed for high-altitude surveillance or targeted air assault, the drone is a powerful and controversial combination of human skill and robotic technology, and a long-range look at the future of warfare. Coming up on Battle Factory, a shock-proof, leak-proof carrier you can drop out of the sky, and a DIY solution to surviving in the woods. These granules of lightweight plastic will be melted and molded into a hard-shell, waterproof case that can be an emergency ward in a box. Until the early 1960s, military equipment and supplies were packaged and transported in wooden shipping crates. They were heavy and had to be pried open with crowbars, and once unloaded, they were trashed. These days, the shipping case is made from composite plastic. Lighter and more rugged than wood, the case can be clean enough to carry medical supplies and tough enough to drop out of a plane. They seal tight to keep out water, weather, and sand, while maintaining a constant atmosphere and sterile environment inside. The ECS case breaks down into the hardware and the body. Grains of sand-colored polyethylene are weighed out, then shoveled into a mold. Then a lid is put on, and it's secured to a robotic arm. First, the mold is rotated so the polyethylene grains inside are distributed evenly. Next, the arm moves into a large oven that heats the poly to 300 degrees Celsius for 20 minutes. Once heated, the granules of poly melt together to form a solid plastic that conforms to the shape of the mold. Then, it's shifted to a cooling bay, where an industrial fan dries it to a hard finish. Still hot to the touch, the cases are pulled from the mold. During molding, solid foam is placed inside the shell. As it cools, the case shrinks approximately 6 millimeters, and the foam inserts help maintain its shape. A blanket prevents it from cooling too quickly. Once it's cooled down, the foam inserts are punched out. After a further half an hour, the excess plastic edging, called the return cap, is shaved off. A blowtorch smooths out the edges, and a plastic soldering iron seals any spots where the shaving created holes. The surface is buffed, and an angle blade X-Acto knife trims off the remaining plastic shards. Finally, a flattening agent is sprayed to remove the unwanted reflective gloss left by the blowtorch. During the Korean War, mobile Army surgical hospitals, or MASH units, were set up as close to the front lines as possible, while still trying to keep the doctors out of harm's way. The result is that many people died on stretchers and in jeeps on the way to get help. Now, cases like the ECS case mean that a hospital could literally be dropped from the sky to the front lines. Sterile, protected medical gear survives the journey and can mean the difference between life and death. First, small metal cables called lanyards are clipped on. These serve as the lid's hinges. Next, a hole is routed and trimmed for the pressure relief valve. This helps to depressurize the case during air transport. Then, the case is handed off to a second workspace where the latches are mounted. Now that the case is assembled, glue is applied to the slot along the edge and fitted with waterproof rubber stripping. Then, the case is submerged to make sure the seal holds. Once it passes the water test, the case is packaged up and prepped for shipping out. No matter what the cargo, at this plant, there's a strong case to be made for it. Coming up on Battle Factory, a how-to guide to putting a roof over your head, and a half-ton pickup that morphs into a super truck. For a downed pilot or a soldier caught in hostile territory, the key to survival is rest and shelter. Elite forces have created training exercises that teach the soldier to build an A-frame shelter that both protects him from the elements and hides him from the enemy. The A-frame shelter breaks down into the frame, the roof, and the camouflage. But before starting on construction, you've got to find the right location. When scouting a location to build a shelter, look for natural camouflage, like a clearing surrounded by a dense thicket of trees, with plenty of fallen branches, twigs, and leaves to use as construction material. The ground should be level so the structure will be stable, and so water will drain away from the shelter. The optimal site would be hidden from view, but still have access to water and food in the form of edible vegetation like berries or mushrooms and bugs for a crunchy protein snack. The first thing to consider is the size of the shelter. It's got to be long enough to provide cover from head to toe. An operative will lie down to mark the length with sticks. Bedding comes first. The shelter is built around it so the frame isn't toppled over while trying to get the bedding in. Tree bark and fir branches create a soft, comfortable surface that separates the body from the ground to keep cold and damp out. More body heat is lost to the ground than to open air. The A-frame is made of 3 strong branches. The arms, which are made of 2 pieces of equal length, support a spine called a center pole, which runs lengthwise from the arms down to the ground. If they can be found, arms with forks at one end are best for supporting the center pole. The length of the arms determines the height of the shelter. Lower shelters do a better job of retaining body heat, but limit maneuverability inside. Flexible cedar branches act as a natural twine to tie the arms together. On June 2nd, 1995, fighter pilot Scott O'Grady was shot down over Bosnia, forcing him to parachute into hostile and desolate forest. Without food or water, O'Grady knew he had to keep out of sight and stay alive until help arrived. He'd have to rely on his survival training. By day, he slept in shelters built with whatever he could find on the forest floor. He traveled by night to avoid detection. Subsisting on plants, bugs, and rainwater he collected in a sponge, O'Grady managed to survive and evade capture for 6 nights before being rescued by the Marines. First, the woods are foraged to collect branches of increasing height to line up with the angle of the central pole. If need be, the branches can be snapped into size or cut with a pocket knife. The roof is constructed by leaning branches against the central pole a few inches apart in order to form slats. Once the slats are complete, young leafy branches are threaded through and piled on to create a weatherproof thatched roof. This thatched roof will keep out wind, rain, and snow while trapping body heat inside the shelter. For a soldier stuck behind enemy lines, survival also means avoiding discovery and capture. So the shelter is draped in natural camouflage made of fallen leaves. It might not be the best night of sleep he's ever going to get, but the survival shelter means the soldier can stay warm, dry, and alive until help arrives. Coming up on Battle Factory, a bulletproof troop carrier that keeps rolling under fire. Take a standard pickup, strip it down, and build it up with ballistic steel, and an ordinary truck becomes a bulletproof fortress on wheels. The Incas Armored Personnel Carrier is speedy, agile, and bulletproof. It can transport up to 10 troops or police in and out of hostile territory at 90 kilometers per hour and keep them safe even under high-caliber weapons assault. World War I saw the advent of the Armored Personnel Carrier, the Mark IX, which was first deployed to the Western Front to safely carry infantry accompanying tanks past enemy lines. Now troops could be transported in larger numbers and dropped directly into combat. While production started in September 1917, only 3 of the Mark IXs were made in time before the war ended in 1918. Even though there were only a small number of APCs produced, they forever changed the way battles would be fought. The Incas Armored Personnel Carrier breaks down into the frame, the chassis, and the armor. The Incas Armored Personnel Carrier starts out as a stock Ford F-550 Super Duty truck. The transformation begins by stripping the truck, tearing it down until all that's left is the chassis, a bare metal frame, and the engine sitting on 4 wheels. Now, it's ready to be rebuilt from the ground up. The chassis is reinforced with mild steel, so it can withstand hard riding without cracking. And the brakes and suspensions are tricked out so they can handle heavy armor over rough terrain. The next step is to add the armor, which creates a virtually impenetrable shell able to withstand explosions and enemy assault. But before it can be added, the ballistic steel, called B6, has to be tested. 1 sample square from each batch is pulled, and 3 rounds are fired into the same spot. If none of the bullets pass through the steel, it's considered ready for use. If the metal fails the test, the entire roll is trashed. The bulletproof metal is put into production, and the armor plating can begin. Shapes are carved out with a laser, including the windows and gun turrets. Next, the armor is bent into shape on a 10-ton press. Ballistic steel is also used to fully encase the vehicle's engine in a bulletproof cage, so it can keep running under fire. By the onset of the Second World War, both sides realized the necessity of mobile command and control in wartime. As a result, APCs were produced and employed by both the Axis and the Allies in much larger numbers than before. And the carriers evolved from simple armored cars to the ultimate in sophisticated engineering and highly effective tools of war. Today, they're an indispensable asset for armies around the world. The APC's frame is made from mild steel. Its low carbon content means the metal will flex instead of cracking under the impact of a bumpy ride or bomb attack. The steel floor fortifies the chassis against landmines. The outer frame is assembled, lowered onto the chassis, and welded together. A layer of foam insulation is sandwiched between the steel plates to protect the passengers from harsh weather, as well as providing another anti-ballistic layer. The B6 ballistic metal is then welded to the inside of the hull, making it completely bulletproof. A projectile would need to puncture the mild steel, pass through the foam insulation, and penetrate the ballistic steel in order to hit and harm the vehicle's occupants. Nearly impossible. Once the truck has been coated with a textured paint that forms an anti-reflective skin, work is done on installing the bulletproof windows, the seats, and the dashboard. After hundreds of work hours, the armored personnel vehicle rolls off the line for a test drive, pushing it to the speed limit on the highway, then knocking it around to make sure it's off-road ready. Converting a stock pickup into an armored vehicle is like turning a mortal into a superhero. And when the transformation is complete, this monster truck is unstoppable. This time on Battle Factory, the survival kit you carry in your pocket. The red dot that's right on target. Battle dress that's bulletproof. And the submachine gun that strikes like a scorpion. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. When these tiny tools are machined and joined together, they will make up the ultimate mini multitasker. Since its invention over a century ago, the iconic Swiss Army knife has evolved into a pocket-sized hardware store with fold-out features that include everything from tweezers to a wood saw. In 1891, in his cutlery shop in Eibach, Switzerland, inventor Karl Elsner came up with a multi-tool which incorporated a knife, can opener, and screwdriver in one compact body, the soldier's knife, and soon became standard issue to the Swiss Army. Today, the Swiss Army knife is used by millions of soldiers and civilians alike for everything from chopping firewood to building a spear. The Swiss Army knife breaks down into three parts: the case, the dividers, and the tools. All the steel tools are made with 13% chrome to make them rust resistant. Before construction begins, the steel sheets are checked for consistency. A spectral analyzer measures the purity of the metal. Spools of 3mm thick steel are transferred to the punch press room. 20 computer-controlled presses punch through the steel with 40 tons of force to cut out the Swiss Army knife's legendary blade. Each strip of steel will produce 30,000 knives. Next, the bottle openers, can openers, and the rest of the Swiss Army knife's many gadgets are punched out. The classic model contains 7 tools, including the penknife and scissors. But some knives, like the Swiss Champ XXLT, have 70 gadgets, including pliers, a magnifying glass, and a ballpoint pen. The blades are placed in huge vibrating machines filled with stones and rubber chunks, which grind against the blades to deburr or smooth the edges. Then the blades stick to a magnetic wheel, which picks them up and drops them onto a conveyor belt. They're deposited into a rotating tank full of sand, where they're dried and degreased. The excess parts are shaken loose in a jitter machine. The knives and other pieces are heated and then rapidly cooled. This alters their molecular structure and hardens the metal. Next, the parts are transferred to the automatic shape machine. The grooves, angles, and inserts are machined into the metal blade and can opener, which enables the user to grasp the tool between their fingers and pull it out of the case. In 1995, during his first mission into space, Canadian astronaut Chris Hadfield used his standard-issue Swiss Army knife to dock the space shuttle Atlantis to the Russian space station Mir. The cosmonauts had secured the hatch with a tough triple-knotted strapping material, and Hadfield simply couldn't untie it to open the door. Unclasping the blade on his Swiss Army knife, he was able to cut the strapping, get the door open, and make history. All the parts are collected and itemized in a sorting room before they're shipped off for assembly. Pins are pressed into the case walls, which hold the entire mechanism together. Each item is placed in layers by hand. Then a machine stamps them into place. A bushing is placed in between layers so that each tool unclasps smoothly without getting stuck on its neighbor. Then the cover is press-fit on, and the little plastic toothpick is slid into its sheath. Before they leave the plant, every function on the knife is checked by hand. The Swiss Army knife is complete. Whatever the add-on, the Swiss Army knife has already earned its reputation as a legendary toolkit and a survival kit you can hold in the palm of your hand. Coming up on Battle Factory, taking aim with laser-sharp accuracy, and what to wear to the front lines. When power runs through this diode and lens, it will project a laser beam that pinpoints a target with total accuracy and plants a red dot right on the bullseye. The Crimson Trace MVF 600 red dot laser sight fits on the rail of a gun, and with its built-in flashlight provides precision targeting in any environment. Red dot laser sights were invented in 1975, but they weren't adapted by the US military until the year 2000. Today, the laser sight is an integral part of the soldier's kit, sharpening aim and enhancing targeting, especially for nighttime operations. The laser sight breaks down into three main parts: the flashlight, the tang, and the laser. The laser consists of a diode, which is an electro-optic, like the little filament inside of a light bulb, and a precision lens. In order to make the laser work, two tail wires need to be attached to the end of the diode, and the lens placed on top to focus the beam. First, the diodes are steadied on a fixture, and then the brass tips are snipped off. Next, the wires are dipped in an acid solution, then soldered to the diode tip. Now wired for power, another technician presses the diode's tail post firmly in place with a coating of epoxy. The bond has to be tight for the laser to project a perfectly straight beam. Then it's left to dry for 24 hours. The lens is dropped into the lens holder. The cap goes over the holder, and the lens system is pressed fit together. The lens system amplifies and focuses the laser beam, which can project onto an object up to 230 meters away. Pulling off a covert operation takes exhaustive training and razor-sharp aim. An elite team might take days closing in on their objective, and then suddenly storm their way past a heavily guarded perimeter. With the laser sight pinpointing their target, that red dot will be the last thing their targets ever see. The laser and flashlight sit on opposite sides of the sight's handle. First, the flashlight's electrical system is assembled, then capped inside the casing. Then, the laser's diode and lens are fit together. Once connected, a tech calibrates the laser beam for sharpness and accuracy. The laser is then locked into its casing to complete construction. The tang contains the laser sight's power supply, housed inside the grip. Once the circuit board is programmed, it's installed alongside the batteries it controls into the handle. The tang attaches under the barrel of the weapon, doubling as a grip onto which the flashlight and laser are mounted. The on-off switch is right on the grip, so the shooter never has to take his hand off his weapon to activate the sight. The laser sight is calibrated to ensure total precision. The MVF 600 is ready for action. On the firing range, the laser sight is tested for accuracy. The beam aims for a target 30 meters away, focusing the red dot at its center. Bullseye. In the real world and combat zone, the MVF 600 will do what it's designed to do with lethal precision. Guide a bullet so it lands right on the red dot. Coming up on Battle Factory, a suit of armor for the modern-day warrior, and looking down the barrel of a submachine gun. These bolts of bulletproof fabric will soon become wearable protection and a soldier's last line of defense. In the past, body armor tended to be clunky, cumbersome, and restrictive. Today, it's built for maximum protection and maximum mobility. Fenix combat body armor owes much of its strength to a lightweight synthetic ballistic material called aramid. Comprised of 82 different pieces, the Fenix body armor is made up of the armored plating and the fabric. Rolls of camouflage fabric are laid out onto a table. Templates of the 60 shapes that make up the vest are laid over the material, traced and cut. A layer of 3D shock protection netting lines the inside of the vest, absorbing the impact of an explosive shock wave or bullet to minimize injury. Camouflage fabric pouches are sewn into the netting that will hold padding and armor. The basic profile is then sewn together to form the front and back of the vest. Heavy nylon strips are sewn into the vest to hold the surface components of the armor in place. Layers of aramid form the soft ballistic protection packets. They're placed in waterproof bags and sealed with an ultrasonic welder before they're inserted into the vest. This process is vital, as any water or moisture in the aramid will compromise its bulletproof nature and make it act more like a lubricant, actually helping the bullet to penetrate the wearer. In a Taliban compound in Afghanistan in February 2008, Royal Marine Corporal Matthew Croucher was patrolling with his crew when he hit a tripwire tied to a grenade. With only seconds to react, Croucher threw his backpack onto the grenade and dove onto it, hoping his sacrifice would save the rest of his team. While the explosion tore up his gear, his body armor absorbed enough of the impact to save every member of his unit, himself included. Croucher was awarded the George Cross for gallantry. The rigid armor is made from plates of strong, lightweight PVC. The smaller segments are die-punched by machine, but larger pieces, like the backplate, are traced, cut, then punched out by hand. Holes are punched out of the PVC plates to lighten the armor. The plates are then sewn into the pouches in the front, back, shoulders, and around the waist. When the vest is tightened, 35 kilos worth of armor plating is spread evenly around the body, taking the stress off the shoulders. Now, the body armor is ready to be assembled. The packets of aramid are inserted into the camouflage fabric, and the 3D shock protection pouches are sealed with Velcro. An additional layer of heavy ballistic material is inserted into the body of the vest. The front and back pieces of the vest are attached to a quick release system, so they can be ripped off to alleviate weight or treat an injury. Then the groin, shoulder, neck, and other padding is attached to the main body. The completed armor is ready for testing. On the firing range, the body armor is draped over a thick block of putty to simulate a human body. First, it takes rounds from a semi-automatic 9mm. Then the armor is checked to see where the bullets might have penetrated. Marks in the putty would be wounds on the wearer. Then the process is repeated with a submachine gun. If the armor survives the test, It will be shipped out to Special Forces units, who will custom kit them to their personal specs when they wear them in the field. And the next time bullets are fired at this armor, it will be protecting flesh and blood. Body armor won't make the wearer invulnerable, but this protective gear can get in the way of a bullet and keep a soldier alive. Coming up on Battle Factory. A single round or full-on automatic, it's the right weapon for any operation. When this steel pipe is drilled and honed, it'll become the barrel end of a weapon that's compact, versatile, and deadly as a scorpion. The Scorpion submachine gun is lighter than a rifle and more versatile than a handgun. Fast loading with a fold-out stock, it can fire single shots, 3-round bursts, or empty its magazine in full auto. Accurate to 200 meters, the Scorpion is the weapon of choice for many military and security forces around the world. And the Scorpion machine gun's ability to shoot with precision is built right into the barrel. The steel used to make the Scorpion's barrel is first left to cure outside the plant. Weathering the rain, heat, and changing temperatures might coat the metal with rust, but it also makes it more durable. First, the barrel is precision drilled to create a hollow running the length of the cylinder. Next, the opening is bored out in 115mm sections. The barrel spins on a lathe to scrape off the rust and smooth out the surface. In a hammer forge, 4 synchronized hammers pummel at the steel 1,000 times per minute with 45 tons of force, extending the length of the barrel and etching out corkscrew grooves on the inner wall. These unique grooves, or rifling, cause the bullets to spin so they fly straight and true. Then, the barrel is cut to length. Finally, a technician inspects the barrel's interior, cleaning out any debris and checking the rifling that makes up this Scorpion's distinctive fingerprint. Any flaw in the barrel could send a bullet way off its mark. The trigger is cut to spec inside a computer-controlled cutting machine. Small components that make up the submachine gun's action, including the slide stop, trigger, and dynamic bolt, are baked in a very hot kiln to harden and toughen the metal. On April 30th, 1980, 6 armed men stormed the Iranian embassy in London, taking 26 hostages and demanding passage out of England and the release of their imprisoned brethren. For days, British police stalled, managing to gain the release of 5 hostages without giving in to terrorist demands. In frustration, the terrorists executed a hostage. With lightning force, the British Special Air Services, armed with submachine guns and stun grenades, stormed the embassy, killing 5 of the 6 terrorists and rescuing all but 1 of the hostages. The SAS solidified their reputation in the most successful rescue op of all time. All in all, it takes about 25 minutes to assemble the gun. Each part must fit precisely to within a millimeter's tolerance. The barrel is attached to the body of the gun. Next, the trigger assembly and slide are inserted into the stock. The Scorpion submachine gun is known as the gun that'll shoot under any condition. To make sure it lives up to its rep, testing goes to extremes. First, the gun fires 2 overpressure rounds, 20 to 30% more powerful than a typical round, to ensure the strength of the gun. Then, the gun is subjected to a 5-round precision test, the results of which are measured by a computer. The Scorpion is built to withstand being dropped from a height without shattering. It can also be submerged until water fills the gun. Once it's completely soaked, rounds can still be fired in full automatic mode. Even when the gun is dumped into thick bogs of mud and coated, it continues to fire. The Scorpion submachine gun combines the best of a full-scale automatic rifle and a nimble handgun. And like its namesake, it's got survival skills and a killer instinct.